Hi everyone, this is Chenyang. I'm a PhD student at Computer Science Department of Dublin City University in Ireland. Today I'm going to talk about our research paper at Text to Story Workshop 2020. As you can see from here, the title of our paper is Incorporating Context and Knowledge for Better Sentiment Analysis of Narrative Text. So the main point of our paper is sentiment analysis, especially for narrative text. Also, first let me introduce our work. The motivation behind our work is there are massive online narrative sources with the rapid development of a World Wide Web for the last 20 years. So there are many online narratives, such as news articles, online stories. For online stories, it can be old stories written many years ago. It can also be new stories written recently and be put on web recently. So actually, web users such as me, we have needs to search those narratives by key phrases and their attributes as well, like the categories, such as if I want to read sports news or political news. And another very important attribute of narratives is their sentiment and emotion inclination, which means if I want to read a novel with happy ending, if I want to read a novel that was with fearful content, with positive content, I want to have I want to search it by narratives, sentiment, and emotion polarity. This is very important for the retrieval. But unfortunately, little research has been done on sentiment analysis for narrative text. If the searching engine can have a very strong sentiment analysis model that can classify narratives into their sentiment polarity with very high accuracy, that can enable a better search and retrieval for online narrative resources, and it can provide a good user experiences for web users like me. So it's very important. But narrative text has its own complexity. It's different from other type of text. First is that it is a perceived sequence of non-randomly connected events, which means the semantic meaning, including sentiment of a narrative, is significantly affected by its context. So the context is very important for narrative. We must take it into consideration. The second one is there are many terminologies. It came from linguistic phenomena such as metaphor. For instance, Achilles' heels means someone's weakness or their despite their overall strength. Those terminologies need knowledge to be correctly understood, making sentiment analysis more difficult. So based on those two complexities, we introduced two new features into our model in this paper. The first one is contextual feature. Second one is knowledge feature. So we're be introducing more details in the next slides. The research background of our paper is that one important point is that we use BERT in our model. So why we use BERT? What is BERT? BERT is a strong pre-trained language model proposed by David from Google. It's very famous and strong. It achieves best performance over various natural language processing tasks such as question answering, textual similarity, and sentiment analysis. Its BERT has been trained on a very large scale corpora. Hence, we can consider that BERT knows more than sentence itself, which means I've explained this, which means that if we input a sentence into BERT, actually BERT knows more than the input sentence itself. If because why it can do that? Because BERT has been trained on a large corpora. It's a pre-trained model. Like BERT knows the connections between Bill Gates and Microsoft, even if Microsoft is not in the sentence, but knows that it captures underlying word associations. So it's a very strong model. It's a powerful model. It has been deployed by Amazon, Google to help web search. So it's a very powerful model. Okay, actually we employ BERT in our model in this paper. Like, this picture is the overall architecture of our proposed model. This is a sentence level model. As you can see from here, this is BERT encoder. BERT encoder is composed of transform blocks. Every block has self-contained layer norm, and feed-forward layer. After BERT encoder, we got a representation vector of every token in the sentence. And this polling layer just simply selects a special token, CIS, just select its its representation vector, and then it fills with we feed this vector and its context vector into linear layer with knowledge, and then we got our sentiment label. So this overall architecture. First, next, we first introduce our contextual feature. So taking context sentence into consideration will make a better text understanding. So we compute as following. Sentiment label equals to arg max y, the probability of y, condition on sentence J and context J. The context J is defined as following. It is composed of the context sentences before the current sentence. In this equation, T is the amount of sentences we use. In this paper, we use which is the last sentence of the current sentence as is context, which means T is 1 in our paper. The knowledge feature is that we use a slide dataset from LREC 2018. It is a multi-word idioms dataset with sentiment annotation. As you can see from it, there are many idioms, behind bars, bounce back, with sentiment annotation. The data set is like this, the idiom and their sentiment distribution vector here. Like Catch 22 is a novel, and 7 you can see from here. This is the total annotators. 7 annotators give negative and 3 give neutral. So this is a negative idiom. We use this. So this is the M is the I subscript I is the sentiment distribution vector in there. We inject knowledge as following. We just simply add the this vector with the distribution vector over the sentence. We just simply add them together and they get the sentiment polarity of a sentence. And other solutions have also been tried. Like where we feed idioms and sentence into Puerto encoder respectively and get sentiment label respectively. Unfortunately, they perform worse. We think that's because dataset is balanced and the coverage of our knowledge dataset is small. So in the M subscript I is the idioms that appear in the sentence. So we add them together to get sentiment label. The data set we use in this paper is a fairy tales data set. It contains 176 fairy tales from 3 sets of children's stories. The totally 15,302 sentences annotated with emotion labels in sentence label. There are 8 labels, like happy, fearful, angry, sad, and neutral. As you can see from here, neutral is most frequent label with 66%. And to train the purpose of training our model, we split the dataset into training set and test set. The label distribution is here. You can see from here. Okay, the experimental results. First, we conduct our experiment on binary classification, which means we classify sentence into emotional content and non-emotional. So it's binary classification. As you can see from here, the model of our with contextual feature performs best. Actually, it's the same. It achieves the same performance with context with knowledge, but actually we think that's because it's mainly because the contextual feature. So as you can see from here, it achieves best accuracy, precision, recall, and F-score compared with all the baselines we listed. Actually, other models such as bidirectional STMs and deep convolutional neural networks have also been tried, but actually they perform worse, so their results are not included. For multi-class classification, since in our knowledge base is incompatible with those with multi-class classification, so there we only have 5 models. As you can see from here, the BERT with context feature also achieves the best performance compared with other model, compared with other baseline models and vanilla BERT. that that proves the effectiveness of our new introduced features. So actually, future work, we want to investigate how to build document model based on current sentence level model. So from sentence to document, there's a gap between them. Second is we aim to build a larger knowledge base for sentiment analysis to improve coverage for text. The third one is we want to explore more sophisticated methods to inject knowledge. As you can see from our paper, we have tried different solutions to inject knowledge, but due to some reasons, they work bad. So we want to explore more methods. Okay, that's all. Thank you. Thanks for listening. If you have any questions, please do not hesitate to ask me. Thank you very much.